So now we're doing FreeCodeCamp Legacy Python for everybody, working with lists. All right, so let's get to it.
Okay, so we've taken a look at loops.
So let's type this down. Concatenating lists using the plus sign. Okay. So let's go down to the bottom. Start it off. We don't need to do that. Let's just go here to the end, right after Ross. And let's say what it says. Concatenating lists using the plus sign. Concatenating. Hold on. Concatenating. Yep, that's it. All right, concatenating lists using plus. Lists using plus. Let's go down. That's fine. All right. So we can create new lists by adding existing lists together. We can create a new list by adding two existing lists together. All right. So this is something different from JavaScript. So let's do that. We'll say A equals, and then we'll have the 1, 2, 3, like that. And then we've got another one. And let's take this, drop this, take this, drop this, and then drop one more. Why not? Let's say print C. All right. Then let's drop it 2 more times, 3 more times, and then just change them up. All right, so this will be this. This will be print A. We'll take this. This is why I want to learn Vim, because I do not want to be using. I want to learn how to do this without using the mouse. You know what I'm saying? I think doing this by keyboard is way better. 3, 4, 5, 6. There we go. And there we go. Okay, so let's go over what's going on. So we can create a new list by adding two existing lists together. Hold on, let's change this. 4, 5, 6. Let's call this B. Call this C. All right, let's see. A plus B. All right. So A plus B. Okay, great. So now there we go. All right, so we can create a new list by adding two existing lists together. So we got this list here, 1, 2, 3. We got B, which is 4, 5, 6, and when we say A plus B, it'll go like this. But what if we do B plus A? Will it put 4, 5, 6, 1, 2, 3? Probably. And when we say print A, it still does this. So it doesn't change A and it doesn't change B. And I mean, why would it? All right, so let's watch him talk about it.
And now we're going to just take a little...
Hold on. Let's look at this. Is everything written correctly? Yes. Okay. Let's go back to the
beginning. Okay. So
anyway,
we've taken a look at loops, and now we're going to just take a little, a bit of a look at some of the operations that you can do with loops. Python has this, as we'll soon learn, object-oriented approach to its operators. And the plus can add strings, and it can add numbers. It can add floating point numbers, integer numbers, strings, etc. And so the plus similarly works this way with lists. The plus looks to its left and looks to its right and says, what am I adding? And in the case that I'm adding the list 1, 2, 3 and the list 4, 5, 6, it concatenates them together. In this way, it sort of functions like a string, and so we get 1, 2, 3, 4, 5, 6. It's just concatenate this list to another list. And it doesn't change A or B, just like in any kind of assignment statement. Calculations on the right side don't change the variables, and then produce a new variable and then assign that into C.
I believe it. All right, so let's see what this says. Lists can be sliced using the colon. Very true. Let's type that down. I thought we already did that though. Oh no, it's we did it to strings. Okay, cool. So let's do that. What it says: lists can be sliced using the colon. Lists can be sliced using the colon. Yeah, that's fine. All right, so now let's type this. All right, let's type this. So we've got T equals, we've got a list. Come on. There we go. All right, we've got 9, 41, 12, 3, 74, and 15. All right, let's put some spaces in there. All right, so we got that. And now we say T, we're going to slice T at whatever. All right, so let's take this like that. Let's drop this off 1, 2, 3, 4, 5, 6, 7, 8. 8 times, right? Do this, and we're going to say 1, 3. All right? And then this line is going to be 41, 12. All right? And then we're going to say slice until 4. From 0 to 4, basically. What do you mean 41 to 2? No, it's just, what? Oh, what? Oh, yeah. Let me show you. All right, so this one is saying slice from 1 until 3. So 0, 1, 41 until 3, 2, 3. So it's non-inclusive of the third, of index 3, the fourth index 3. It's not including that, right? When we do 1 through 3. So 0, 1, so it's just going to take 1, 2, but not 3. All right, so that's why it's 12, 41, and 12. Then we're going to say from 0 to 4, basically. That's what this is. So 0, 1, 2, 3, 4. It's going to print out all of these. Okay, so let's get rid of this like that. All right, so it's going to print out this. It's not going to print, actually, it's not going to print anything. That's just what it's going to be. I don't know why these aren't print statements. Anyway, whatever. All right. So now we're slicing from 3 to the end. That's what this one is. We'll say that from index 3 to the end. Okay. So we'll start at 3, 0, 1, 2, 3. So 3, 74, and 15 should be what's in there. And yeah, that's what it says right here. So let's get rid of that. So let's get rid of that. All right. And then we're going to say T with no T slice with nothing on either side. Like that. Is going to just give us the original, whatever T actually equaled. And, you know, this looks stupid. This definitely looks stupid. Like, what are you going to do that for? But I've never thought to use it myself, but I have seen in people's code clever ways to use this principle. You know, there are reasons to use this. This does get used. They're very clever too, but I don't remember them right now. All right, so let's type what this says. So remember, just like in strings, the second number is up to, but not including. Let's take this. Actually, let's take this, do a Control X, and that is talking about this line. Let's do that right here. Let's put that here. And let's go to the home, and let's bring this back a few. There we go. Good enough. All right, so let's hear him talk about it.
You can also use list slicing, and it's easy to remember. If you remember how strings work, list works exactly the same way. So it's, of course it's a little tricky. The first number is the starting position. They start at 0. Mm-hmm. So 1 is right there. So it's the 0 position, the 1 position. Start at 1, right? But go up to, but not including 3. There's 1, 2, 3. So this goes up to, but not including 3. And that's why we get 4112 out of that. So up to, but not including. I'll just say that over and over and over again. If we do, you can leave the first part out. You can leave the first part out here, and you can say, oh, up to, but not including 4. So that starts at the beginning, goes up to, but not including 4. And so that's how we get that piece right there. We can say start at...
Was there a cut right there?
That piece right there. We can say, but not including 4. And so that's how we get that piece right there. We can say...
maybe not, no.
Start at the position 3, 0, 1, 2, 3. Start at position 3 and go to the end. Now the fact that the number 3 is in here is sort of irrelevant. 3 to the end is those 3 numbers. And then you can do the whole list with slicing as well. Again, these pretty much are the exact same examples I used when I was doing strings. They're pretty much the same. There's a number of different...
All right. List methods. Let's type this down. All right. So list methods. X equals list, like that. Type equal type X, all right. And so when we do this, it's going to give us type list, okay. And then we'll say dir X, and then it'll give us append. It'll give us all the methods we can use on this thing. All right. So that's basically what this is talking about right here. I only know this because I've seen it. I think we did this earlier and I understood what was going on. Hopefully. But anyway, yeah. Let's watch him talk about it.
Different methods, and you can look up all the documentation in list. I often just use the dir command to remind myself of them. Append we'll look at. Count looks for certain values in the list. Extend adds things to the end of the list. Index looks things up in the list. Insert.
Let's do this. Let's do this. Let's say right here, let's do a little arrow. Let's say prints out all displays. Let's put displays. Displays all of the list methods. All right, cool. That's good. All right, so let's keep going.
Allows the list to sort of be expanded in the middle. Pop pulls things off the top. Removes an item in the middle. Reverse flips the order of them, and sort puts them sorted order based on the values. So let's look at a couple of these.
All right, let's do this. Let's write this down. Building. What did it say? Building a list from scratch. Let's do that. let's do it here. Building a list from scratch. So we can create an empty list and then add elements. There we go. Using the append method. Oh, okay. What else can we do? The list stays in order and new elements are added at the end of the list. Okay. So let's type what they're talking about. All right, so we can create an empty list and then add elements using the append method. So we say stuff equals list. Okay. Turns out, so we can do this. We'll say stuff. Let's do the chevrons thing. Stuff equals list. All right. Let's see. List. The list stays in order and new elements are added at the end of the list. Okay. Okay, I know what we'll do then. All right, so now let's come down here and let's do some more chevrons. Stuff dot append. Come on now. And we'll say book right here. Then we'll do on the next line, let's say stuff dot append 99. Now let's format the rest of them. So we need 1, 2, 3, 4, 5 more lines. So let's take this from here to here, drop it off 1, 2, 3, 4, 5 times, and let's change it up here. So when we print, we're going to print stuff on this line. So we'll say print stuff. All right. On this line, it's going to give us what we printed, which is going to be book and 99 in this new list because we just appended them, right? We just appended both of these things onto the end of this list. This was an empty list to begin with, right? I'm pretty sure if we printed stuff here, like if we did a print stuff on this line, it would probably give us just an empty list. But, you know, hopefully that's true. Let's do, so stuff.append cookie. Let's throw cookie in there. So we've got this and say cookie. And so when we do print stuff again, whoops, not there though. Print stuff again here. What it's going to give us is this with cookie at the end of it. Just like that. So that's what he's saying right there. Let's go. I got coffee too.
The order based on the values. So let's look at a couple of these. So if we build a list from scratch, we have a way to ask for an empty list. There are a couple of different ways to ask for an empty list. We could use just 2 square brackets next to each other, but this is a form we call the constructor form where we say, hey Python, make a list. In this case, the word list is like a reserved word to Python. It's really a reserved class, but...
All right, so let's put that there. Let's say, that's the constructor method. Python constructor method. Python constructor method. Let's capitalize it all. How about that? Let's do title case on it. All right, so there's that. Let's keep going.
Say list parentheses says make me an empty list, and then assign that list into stuff. So stuff is now it's a list object. It's of type list, but it has nothing in it. And then we can call the append method, stuff.append, and stick book in. And then we say, oh, and that knows how long, the stuff knows how long it is, where the end is, and how to add something to it, and then add a 99 to it, and we print it out. We got book and 99, reminding ourselves that lists, while they're often the same types of variables, same types of values in the various positions in the list, it doesn't always have to be that way. Then we say, oh, we'll stuff that append cookie. You can keep on going, and then we end up with 3 things and the cookie. We have an in operator. Works pretty much like the in operator.
All right. So let's type this down. 1, 2, 3. How about that? All right. So is something in a list. Let's do that. Is something in a list? Question mark. Python provides if and provides 2 operators that let you check if an item is in a list. Drop this down about right here. How about that? All right. These are logical operators that return true or false. Okay. They do not modify the list. Okay. So Python provides 2 operators that let us check if an item is let us check if an item is in the list. All right. So let's type this out and then we'll try to figure out what they're talking about. So sum equals, try to translate it into a normal speak. Okay, 1, 9, 21, 10, 16, and that's it. All right, let's put some spaces in there. So sum equals that. All right. In, oh, not in. So they're talking about these 2. Okay, I see. So let's tab this over. And let's tab this over, do this, and say 9 in sum. All right? And if we do that, let's take this and look at this and say 1, 2, 3, 4, 5. Let's do this 5 more times. Oops, starting from here. 1, 2, 3, 4, 5. So we've got true here. So this is going to give us true. All right? If we say 15 in sum, this is going to give us false because there's no 15. It's just 16, right? 20 in sum. Let's do that. Is there a 20? No. What? 20 not in sum. 20 not in sum. And that's going to give us true because 20 is not in sum. All right? So that's the 2 operators. Check if an item is in the list. Yeah. Let's take this, slap it here, press delete twice. And then let's also say colon in and not in. All right. Let's wrap this like that. Not like that. Like that. And oops, like that. I know we never go back and read the notes, but I just think it's a good habit. It's good to get in the habit of at least formatting it right, just in case, just in case. All right, so let's do that. So, okay. So Python provides two operators that let us check if an item is in a list, the in and the not in operators, all right? So we see here, sum is this little list right here, 9 in sum. There's the 9. It's true, yes. 15 in sum. There's no 15. It's false. 20 not in sum. There's no 20, so it's true because there is no 20 in sum. So this one's may get confusing at some point, but we'll get used to it as we go. Let's listen to him talk about it. Okay. Oh, also, these are logical operators that return true and false, like we see right here, and they do not modify the list, as we can also see where this is not getting modified. All right. So now let's look. Now let's watch.
Operator in a string is 9 in my list, and that's pretty simple, and the answer of course is yes, 9 is in my list. Is 15 in my list? Looking through, no it's not. 15 is not in my list. And then there's the not in operator. You can think of that as kind of like one operator. Is 20 not in the list? And the answer, since it's not there, is true. And so that's a way to just, it's kind of like starts with or in for strings, same kind of stuff. Lists.
Okay. Let's write this down. All right. What did it say? Lists are in order. Lists are in order. You get tired and you just get listless. Is that the word? Let's go ask the expert. Hold on. Hold on. We should have just did it on there, but whatever. Listless definition. Oh, there it is. Lacking energy or enthusiasm. Ah, well, whatever. Lacking energy or enthusiasm. Yes, a person gets listless. A list can hold many items and keeps those items in the order. Okay, in the order until we do something to change the order, and keeps those items in order, not in the order. All right, that's what was confusing me. Okay, cool. What's next is a list can be sorted, yeah, i.e. changed. We don't need that. We know what sorted means. All right. The sort method unlike in strings, means sort yourself. What does that mean? Well, that's why we're watching this video, right? Okay, so yeah, we're gonna have to put change its order. I period E period change its order. Yeah, I don't know what this means, so we're gonna have to watch this. Or maybe we'll get it right here. So friends equals the friends. Let's go get the friends while we're chilling. Joey, Chandler, and Ross. I got you right here, my boys. All right. Let's tab it over. Boom. There's that. So when we say friends dot sort. Oh, we're on the. Okay, so here's the sort right here. So let's do that here. Friends dot sort. Okay, so this goes along with this. So let's do this. And so it's going to put the friends there, but without these spaces. And then when we say print friends at 1. Wait, no. What order did this put this? So it would put Chandler first, then Joey, then Ross. So we would do this. All right. And so when we said print friends at 1. Froham's friends at 1. We would get Joey, right? Because Joey is right there. Is 0, 1. All right, so that's basically what's going on here. Let's read this. Let's just go over it one more time. So a list can hold many items and keep those items in order until we do something to change the order. In that order. In its order. And keep those items in its order. In order, whatever. All right. A list can be sorted. All right. So we can sort it. And the sort method, unlike in strings, means sort yourself. What does that mean? All right, let's listen to him talk about it. I said.
Are in order. Starts with or in for strings. Same kind of stuff. Lists are in order and they're sortable. And so this is something that we take good advantage of. A lot of what computers want to do is sort stuff. You know, look all these things up, append them, and then get them sorted. And so there is this method inside of list that's just the sort method. So here we, put 3 values in 0, 1, 2 position, 0, 1, and 2, Joseph, Glenn, and Sally. And then we tell the list to sort itself, and then we print it out. Now this is actually sorted the list in place, which is different than upper and lower, because if you remember, strings are not mutable, but lists are mutable, and so you say, hey, just sort yourself. Okay, and so just sort yourself, and then it sorts it, and then it's in alphabetical order, Glenn, Joseph, and Sally. I happen to be clever. I only put strings in there, and I put my uppercase and lowercase in a very consistent pattern, but the list is changed. And if I look at list sub 1, that is the second item, which is Joseph, that prints out right down there.
Right, but what if it was, mixed types? Whatever.
There's a whole...
All right, whatever. These streamers, they really do, this is really not as easy as you would think. We don't do things because they're easy. I don't stream because it's easy. I stream because I thought it was going to be easy. Built-in functions and list. All right. Built-in functions and lists. Oh, my back's starting to hurt and everything. My goodness, this is actually... There are a number of functions built into Python that take lists as parameters. Okay. Remember the loops? What? These are simpler than loops. These are easier. Hold on what is this? This is Python. This is the Python course. This is like once you're done with the HTML and the CSS and the JavaScript, then you can come on over here to Python and learn how to do more coding. I guess that's basically it. So these are easier ways. These are easier to use than loops. I guess that's what that says. All right, so let's start with this last one, or this top one. All right, so what we're going to do here is we're going to say nums equals, and we're doing 341 12 9. I think we already had this, but I forgot. 74 and 15. All right, just give them some spaces. All right, so we got this, and then we're going to do print in the next line, print, and then we'll print the length of the nums. So we'll say len, we'll go nums, and because there's 6 of them, let's go over here. We've got 1, 2, 3, 4, 5, 6. We got 6 of them, so it prints out 6. All right, and so we've got the other things going on. So this is just like the string functions. All right, so we can say like print max nums, print, and then we'll do max of nums. And let's grab this and drop it off. We're gonna need it 1, 2, 3, 4, 5, 6, 7 more times. 2, 3, 4, 5, 6, 7 more times. And so this, when we say print max nums, it's going to go through and it's going to find the maximum, which is going to be the largest one is 74. It's going to print that out. So then we're going to print min nums. So let's say print min nums right here. Print min nums. And what this is going to print out is the minimum, which is going to be 3. It's going to be the smallest one. All right. And then we're going to say sum nums. So we'll put the sum right here. So it's going to add them all together, 3 plus 41 plus all this, and I don't feel like doing the math on that, so let's just trust that it's 154, right? And then we're going to print sum nums divided by len nums, so basically making the average. So let's do sum nums divided by, and then we're going to do len nums. So it's going to get 154 and divided by 6, and what that's going to give us is 25.6, thusly giving us the average of each one of these numbers. All right, and that's basically what we're going to be learning about these built-in functions. Let's watch.
A bunch of built-in functions to help manipulate lists. The other thing. There's a whole bunch of built-in functions to help manipulate lists. The other things I was showing was sort is a method that's part of lists, but there are other functions that take lists as their arguments. We already talked about the len function, tells you how many items there are. There is pretty obvious max, it says go through and find the largest. Min, go through and find the smallest. Sum goes through, adds them all up. And we can say let's do average by taking the sum of all of them and dividing it by the length.
That's what I've been doing the whole time, except for I haven't been streaming it. You know what I mean?
And you might think to yourself, oh wow, I wish we'd have known this a few chapters back when we were having to write all those loops to do max, min, sum, largest, smallest, etc.
Wait, did we not do this?
Think in your mind that inside each one of these functions is a loop that does pretty much what you did in those chapters. And part of the reason we did that back then, even though these things were here, was they're kind of easy loops to understand. And so
true.
Those are there. And
okay. Oh my God, what do we got to do here? Let's write this down. Let's type this down. How long is this video so far? 38 minutes. 38 minutes for a 9-minute video. Why is it got to be so hard? All right, so let's go to the next one. Total equals 0. Count equals 0. Let's type that out. Does this even have a title? No. What's going on here? Anyway, let's just type it out anyway. All right, so total equals 0. No, let's do it like this with a tab. Total equals 0. All right, let's take this from here to here, copy it, and then we're going to drop it off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. There we go. All right, so count. Let's change this to count. While true. So while true. So while true is whatever. What? Oh, what? Anyway, well, let's type this down and then he'll tell us what's going on. So input equals input, and then we'll say enter a number with a space, so it looks good. All right. So if input, we're still inside of this. If input double equals done. If input double equals done, what we're going to do is break. Is this how we do it? I guess that makes sense. All right, so we've got that. So now we've also got this value. Value equals float imp. What? Oh, right. He's going to tell us, but let's keep writing it down anyway. Total equals total plus value. And then we're going to do count plus count equals count plus 1. We haven't learned plus plus yet, or whatever. Or plus equals. All right, so we've got that. Oops. We've got that. This is going to be a blank line. And so now we've got average equals total over count. Okay. And then we're doing print. And then we're going to say average. And then we're going to also print the average variable. Average variable. Okay. So that's this one. I don't know what we're going to call that, but what? Oh, so it's waiting for it to be for us to write done, and then it'll break out. Okay, that's what's going on. And then it does this. Okay. What's this? All right, let's do that. So, okay, let's put this here. So it'll say, let's call this something. Let's call this average.py. That's what this is. Okay? And so we're gonna be over here, and we're gonna start off by calling Python average.py. All right? And then it's going to say down here, it's going to say enter a number. And then we're going to enter 3. All right? And then we'll do it again. And we'll say, let's take this. Enter a number. We're going to do 9. And then we'll do it yet again. We'll get 5. And then we'll come down here and we'll enter a number one more time, but this time we're going to say done to it, right? So that it'll break. And this is just a simple thing. You know, we're not going to offer this to people at the ATM or anything like that. And then we're going to say average is 5. And then how many is this? 3, 6, 9, 10, 11. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like that. And then that's basically what's going on there. So now we've got this next thing, whatever it is. Let's put this to delineate. All right. So we'll have num list. Let's bring it over one. Num list equals list, like that. All right. So it equals the list method. Let's grab this, copy it. 1, 2, 3, 4, 5, 6, 7, 8. So let's drop it off 1, 2, 3, 4, 5, 6, 7, 8 times. Bring this down a little bit. All right, there we go. So now we've got while true. Let's take this. Since it kind of looks the same. Let's take this. Let's fix it up. We'll fix it up. So 1, 2, 1, 2, 3, 4, 5 lines. So let's take these 5 lines and drop it here. 1, 2, 3, 4, 5 lines. All right. Now let's get rid of this. Ugh. Formatting sucks, but it's important. If it wasn't important, I wouldn't do it. All right. So we got while true, this stuff. So input, enter a number. Okay. If done break, float imp. And so right now on this one, we're doing something different. Num list dot append value. Okay. And we're not worrying about this. But we do have these next 3 lines. So let's get rid of this. And then we'll say average equals sum num list. All right. And then we're going to do len num list. All right. And then we have print average and average. Are these the same things? Do these do the same thing? Do these do the same thing? Let's look at this. That's probably what's going on here. All right, so let's look at this. Okay, so while true, input equals this. So it's like that, right? So we would enter numbers. Okay. Num list equals list value. Oh! So what? What do you mean no? So they're not the same. They are the same. Look, because we're going to append the value. So whatever the value is, because the value would be float here, we're appending it to the list. All right. So the list is nothing. Num list is nothing. But by the end of this thing, by the time we hit break, it's going to be filled with, the num list is going to be filled with 3, 9, and 5. Right. Of course. And then when we say average equals sum of num list over len of num list, we can get it. So this is the easier way of doing this because you don't have to think and this stuff is already available to us. I bet that's what he's going to say. Let's watch.
Basically, there allows 2 different ways of building loops.
See, 2 different ways. Look, that means they do the same thing.
It's not necessarily all that much easier to to do something using these because you either can do them the old way or you.
Now I have to enter a float number, and then the function append are getting called to put that float number inside the older list. This list, it's the same thing, basically.
You can make a list and then use these functions. So let's take a look, and I'll just say that these 2 bits of code are doing the exact same thing. And what they are is they're implementing a program that's going to repeatedly ask for numbers until we type the word done, and then it's going to compute the average and tell us what they are. And so using sort of the stuff from the loop chapter, we start with a total variable and a count variable, set them to 0, and then we read a number, we check for done to break out, but then we convert it to a floating point value. And then we say total equals total plus value and count equals count plus 1. And so this is going to run over and over and over again, however many times we're going to do this. And then it's going to pop out, and when it's done, it's going to have this value of total. The running total will
That's right. Let the professional profess.
Divided by count, and it'll print the average out. Okay?
Just kidding.
And so that's kind of how we would have done this before we knew how to do this with lists. Now, let's take a look at the other one. In the other one, we say, let's make an empty list. Remember, this is that constructor syntax that says to Python, make me an empty list and assign the empty list. It has nothing in it, right? But it is a list, has nothing in it, into the variable num list. Now we're going to write another loop. This part here is the same, these 3 lines. Read the number, if it's done, quit, and convert it to value. But instead of doing the actual calculation right now, what we're going to do is just append it to the list. So the list will start out empty, then the 3 will be in the list, then the 9 will be in the list, then the 5 will be in the list. So we're appending, each time through the loop, we're appending into the list. So we're just growing the list every time I read a value, instead of actually computing something with the value that we've got. So in either case we get value, and in one case we append it to the list. And then finally it finishes, the break happens, and then we just say, oh, hey, Python, sum up everything in the list, add these 3 numbers together, and then divide it by the length of all those things, and you'll have the average. And so these 2 things give us exactly the same output. Now there is one difference.
Boom.
If there was like 1 million or 1 billion numbers, they actually have to all be stored in the memory simultaneously, whereas here it's actually doing the calculation of the billion numbers and not using up so much memory.
True.
For most of the things that you're going to be doing, the difference in memory, there is a difference in memory. This one here uses more memory.
True.
But I can't draw very well. More memory. It uses more memory, but it doesn't really matter by the time it's all said and done. And so for you, the difference between these things is not all that significant, but it's important to understand.
Look. He's saying that right now, but the thing is, a lot of reasons people use Python these days is for large data, big data. And so when you have like billions of things, this does make a huge difference. And like if we ever go over to LeetCode, right, and do LeetCode, all day long they're talking about efficiency over there, all day long. So I mean, this guy, look at his hair. He retired before big data got big. You know what I'm saying? He retired from coding, from actual programming, and became a professor before big data became huge. But yeah, this is incredibly important when it comes to big data. Let's go.
They're just 2 techniques to accomplish the same thing with lists.
And that's that, finally. All right. So let's come over here. Which method is used to add an item to the end of a list? Which one? I'm pretty sure it's append. All right. Let's check the answer. Looks good. And submit it. All right. So now we're on to strings and lists. And we'll see you next time.